Number 30, as the reaction progresses toward equilibrium, the rate of the forward reaction. Well, if you guys think about it, this question is not something that you would even have to refer to the diagram or the given information in the question, because this just logically makes sense, right? The forward reaction is what you use the reactants in order to produce the products. And the reverse reaction is backwards, right? You grab the products and you turn them into reactants back again. Well, in the beginning, you have zero products, and all you got is all these reactants. So in the beginning, a lot of collisions are happening among the reactant molecules. So in the beginning, it's quite fast. But what happens? As the equilibrium is about to be established, well, now the forward reaction kind of slows down a little bit. And, obviously as the reaction progresses, the reverse reaction in return fastens up, right? Because if you guys look at the very idea of equilibrium, if you remember, concentrations of your products versus reactant over time, right? For your product, right? It goes something like this, right? Because in the beginning you have zero product, right? So this is for your product, because in the beginning you have no product, but as the reaction progresses, you create all these products. And then, so in the beginning, it's quite fast. And then as you can see, kind of levels off. And that is the point of equilibrium. And obviously for your reactant, it's going to be the complete opposite, right? It's going to start like over here because you have a lot of reactants in the beginning. And then it starts to decrease pretty sharp because, you are using them up. And then at one point, once again, just like the products, it also kind of levels off, and that's where the equilibrium is established. So long story short, the rate of the forward reaction should be pretty fast in the beginning, and then it kind of slows down afterwards. So the answer has to be something to do with decrease, so get rid of A and B. And it says decrease to become a constant non-zero rate at equilibrium versus to become zero. Absolutely not zero, because if you guys refer back to that equilibrium video I have on this channel, the whole conceptual video on the equilibrium concept, well, I talked about how equilibrium is not a static phase. The forward reaction is continuously happening, and so is the reverse reaction. It's just that the rate at which the forward happens is equal to the rate at which the reverse happens. So that's why you don't really see any change, but that doesn't mean it's not happening. So there are still these rates. I don't know what, but there are rates that are non-zero. That's why answer choice C would have to be correct.